Hello, I was assigned chapter 23, problem number 19. So, problem number 19 reads as a multiple concept, example 3, reviews some of the basic ideas that are pertinent to this problem. A circuit consists of a 215 ohms resistor and a 0.200 Henry's inductor. These two elements are connected in series across a generator that has a frequency of 106 hertz and a voltage of 234 volts. So A asks what is the current of the circuit, and B asks us to determine the phase angle between the current and the voltage of the generator. So this problem derives from section 3, circuits containing resistance, capacitance, and inductance. So just to review that section, we have that our VRMS equals our IRMS times our Z. And our Z is the impedance of the combination. So the combination is R squared plus XL minus XC squared, and that's the square root of that completely. And then we also have the tangent of the phase angle between current and voltage in a series RCL current, which is given by this equation. So XL minus XC over your R. And then lastly, we have the average power, which is equal to IRMS times VRMS times cosine angle, where cosine angle is called the power factor of the circuit. So whenever a resistor, a capacitor, and an inductor are connected in series, the RMS voltage across the combination is related to the RMS. And we see that within this formula right here. So we can go ahead and get started on the problem. Our R is 215 ohms, our L is 0.200H, and this is a circuit connected in series. So we have our F, which is 106 hertz, and our voltage, which is 234 volts. So we're looking for the current for A. So in order to find the current, we're going to use the formula V equals IRMS times Z. So we need to figure out our Z. But in order to do that, we need to have our R squared, our XL, and our XC. So I started off by finding our XL, which is equal to 2 pi FL. So I did 2 times pi times 106 hertz and multiplied that by 0.200 henries. And that gave me a total of 133.20 ohms. So I can plug that into this formula right here. Now our XC is 0 since there is no capacitor in the circuit. So that brings our formula to R squared plus XL squared. So our R is 2.15 ohms, and you square that, plus our XL, which I just found up here, which is 133.20 ohms, and you square that. So after squaring those two numbers, you add them, and then you do the square root. So in the end, my Z was equal to 252.91 ohms. So now that we have our Z, we can go ahead and plug that into our V equals IRMS times Z equation. So we're looking for the current. So we manipulate the formula to be V over Z. And our V above is 234. So we do 234 volts over 253 ohms, which gives us a total of 0.92 amps. So that's our current. B wanted us to find the phase angle between the current and the voltage of the generator. So in section 3, we see that we have tangent angle. So I'm going to use this formula right here, which is equal to XL minus XC over R. So once again, we don't have a capacitor in this circuit. So that's just 0. And then our R is 215 ohms. And then our XL is 133.2 ohms. So in order to find the angle, we manipulate the formula to be tangent -1 times XL over R. So we plug those numbers in. So we do tangent -1 in your calculator, and then we're going to do 133.2 divided by 250 ohms. And the final angle is 31.8 degrees. And it's pretty straight to the point. Thank you.